Good day, viewers. You are welcome to Soluble Tutors. This is where we discuss and we lecture about mathematics, physics, and chemistry. So today we'll be going on a topic called alkylation of benzene. Alkylation using Friedel-crafts methods. This is a benzene ring, and this is methyl chloride. This is methyl chloride. Okay. Talking about alkylation, the alkyl here is the methyl. This is the alkyl that is here. This is the alkyl. Okay. How can we deposit this on this to give us this? Because when benzene reacts with methyl chloride, when they react with methyl chloride, so it gives us methyl benzene. Methyl benzene, because methyl has been deposited on it. So methyl benzene, and subsequently HCl as a byproduct. So this is what we call Friedel-crafts alkylation. Now, let me now show the mechanism. How does it happen? Let's show the formation of the what? Electrophile. So, the formation of the electrophile. What are electrophile? Electrophile means electron lovers. Electron lovers. And what will love electron will be positive because electron is negative. Okay? Because unlike charges attract. So before you can love electron, you will be positively charged yourself because electron is negative. So that's why alkyl is an electron lover. So let's produce the electrophile now. Formation of the electrophile. How does it happen? Now, this and this react to form this in the presence of aluminum chloride as the catalyst. So what happens is that aluminum chloride attacks this reagent first. Attack the reagent first. How do they attack? Now, CH3, Cl attacks AlCl3. They react together first. What happens? This one is having 1, 2, 3, 4, 5, and 6 electrons. Okay, in the outermost shell, there are 3 unpairs, 3 paired electrons. This is paired, this is paired, this is paired. Now, what happens is that this goes, electron is negative. It goes to attack this because this is also having some lone pairs of electron. When it attacks this, it gives us this. We now have CH3 plus AlCl4 minus. Okay. This is having a plus, this is having more than enough electron. This is having a deficiency of electron. Now, this itself is called an electrophile. This is called an electrophile because of the positive charge. It's an electron lover. It needs an electron. So this is what we react now. So what's the next thing? The next thing is for us to have our benzene ring again. We have our benzene ring. Okay. Now, our benzene ring have hydrogen all over naturally. But we are bringing this out for you to see how the electrophilic substitution reaction occurs. What happens is that this electron, okay, we move this electron because this pi bond is an electron. It moves to attack this electrophile because this is an electron lover. So this electron goes to attack it. When it attacks it, it gives us another structure. And the structure it gives to us is this. So we have something like this as our structure. Okay. So pi bond is here, pi bond is here. This pi bond has disappeared. Okay. There is an hydrogen here, which is this. Now, this has been attached to it, which is CH3. That's our alkyl, because we call it alkylation. This is our alkyl. is the methyl, specifically in the alkyl group. Okay, and this is there as usual. But because there is no electron here, this one has 1, 2, 3 has completed carbon having 4 bonds, but this one 1, 2, 3 it has not completed. So there will be deposit of plus sign here, deposit of positive. This positive is also very reactive. Okay, and what happens after this positive is there? What happens? This hydrogen will be attacked, by one of the excess chlorine here. Okay, because naturally this is aluminum surrounded by chlorine, okay, and there is a negative. So one of the chlorine attacks. So one of the chlorine comes for this hydrogen. When the chlorine attacks the hydrogen disappears. Once it disappears, the bond of the hydrogen comes back here, which makes this place balance again and become the benzene ring once more. So from there we have this. So when this attacks this hydrogen, the next thing that happens is that we have another product, and the product is this, the benzene ring again. Okay, you can see this has come back here. So we are having our CH3, and this is called methyl benzene. So this is an alkyl group of benzene. Okay, so we call it alkylation. Let's go for another similar thing. Okay, at this end now, this is also benzene. Okay, this is called ethyl chloride. This is CH3CH2. It follows the same mechanism in the presence of aluminum chloride. Okay, as usual, going by the mechanism, I will be very fast now because this is a repetition. Going by the mechanism now, it means CH3 CH2 Cl plus AlCl3. As usual, this is having some pi bonds. It comes here to attack to give us CH3 CH2, okay, plus another Al surrounded by 4 chlorines, okay, and it's having minus. Now when you have your benzene ring, okay, you have your benzene ring, what happens next is that this pi bond comes to attack this. Okay, when it attacks, it gives us something like this in the mechanism. So in the mechanism, we are having hydrogen, which is this one as usual. This one has come to attack, so it will be there CH3 CH2. Okay, at that time this is not there again because it has gone to attack, so there's nothing there again. So what now happens is that it has deposited the positive charge here. Now one of the chlorine comes back as usual to attack this. Once it attacks the hydrogen to form HCl, because HCl is always the byproduct, to form HCl, what will now happen? Another thing forms. So once it attacks, this one comes here to become the pi bond again. So we are having this. CH2 CH3. That's what should be here also, CH2 CH3. So CH2 CH3 is here. So we call this ethyl benzene. That's normal. This will now give us plus HCl. So by this explanation, I believe you understood very, very well what we mean alkylation of benzene using Friedel-crafts AlCl3 as the catalyst, which will attack our reagent before the reagent deposits our key group on this. Thank you for watching this. If you really enjoy this video, please subscribe to our channel, like this video, and share with your friends. Thank you and see you next time. God bless you as you listen.